All right, hi everybody. Today is 6.5 on two variable inequalities. This is the last section of Module 6 already. It was a pretty quick module for us. But we want to talk about two variable inequalities today. So first of all, let's talk about what I mean by one versus two variables. Everything we've done so far this module has been a one variable inequality. It had just x in it, or maybe just y or p or q. It doesn't matter what the letter is, but you just had one variable in it. So our answers were all graphs on a number line. If you only have one variable, there's only two ways it can go. Positive is right, negative is left, that's it. Just one line. Whenever you have two variables, if you have, let's say, both x and y, remember the letters can be anything, but x and y are the most common ones. That's when you graph it on a coordinate plane. You have the x-axis and the y-axis. And that's when you plot points, like the point 2, 5 means over 2 and up 5. So, solving a two-variable inequality can only be done by graphing. Remember, when we solved one-variable inequalities, we actually solved it. Like we added this to both sides or to all three places, divide this, eventually we get the answer. Negative 2 is less than x is less than or equal to 10, something like that. You can't do that with a two-variable inequality. You can only do it by graphing. The solution is going to be a shaded part of a graph where you're basically saying every point in this shaded area is an answer to this question. So let's talk about how to find that shaded region. If you want to solve a two-variable inequality, the first thing you do is graph it like it was an equation. Just say, I don't care if it says less than, greater than, less than or equal to, greater than or equal to. Pretend like it was an equal sign and just graph the line. It might be y equals mx plus b, might be general form, use the intercepts. We'll take a look at some examples today to refresh on how to do that. But you're going to graph the line. Now, here's the difference between an inequation and an inequality. The first thing you're going to do is to decide when you draw the line itself, you want to decide whether to just draw a nice solid line or sometimes we're going to do a dotted line. Now think of this the same way as when we do open and closed circles on a number line. The dotted line is like the open circle. If you have a greater than or a less than, instead of just drawing in the line, draw a dotted, like a hyphenated dashed line. If you have the greater than or equal to or the less than or equal to, just draw it normal. Just draw a regular, solid, normal line. Now, the answer to the question is either going to be all the points on one side of that line or all the points on the other. And it's going to be exactly split by that line. That's why that line is so important. So basically, once you get the line down, every point on one side of that line is an answer, and every point on the other side of the line is not an answer. So now we have to figure out which is which. And the way we do that, you choose any point that is not on the line. It's very important that you don't pick a number that's right on the line. You have to pick something. In fact, I try to pick something that's not even close. So I'm sure of where it is. Now you take that point that you've chosen, take the x and the y from the point, and substitute it into the original problem. You're going to do some work. You're going to plug in this for x, plug in this for y, multiply, add, do whatever you need to do. Eventually, you'll get an inequality. Now, I said in the notes, if it works. What I mean by if it works is like if you get 2 is less than 5. And you go, yeah, 2 is less than 5. That works. Well, what that means is that the point that you chose is one of the answers. But more importantly, it's on the right side. So you like everything on that side of the line is the answer. Now, then I said if it doesn't work, then you're on the wrong side. So let's say I pick an x, I pick a y, I plug in, I do the work, and it ends up saying 20 is less than 10. And you go, that's not right, 20 isn't less than 10. That means you picked a point from the wrong side. It doesn't mean you did the problem wrong. It just means that that side that you picked from is the side that are not the answers. You don't have to test another point, just go and shade the other side. So let me do a couple examples. I'll show you guys exactly how this works. So let's graph y is less than negative 1/3 x plus 4. All right, I am going to draw on a coordinate plane right here. Mark some points. Now remember, when I do this for the notes, I always draw my own coordinate plane, but remember, I always have graph paper for you in class you can borrow. Much easier to do when you actually have graph paper. Okay, so let's review our graphing lines. This is like, even though it's not an equals, it's a less than, it's basically slope-intercept form. It's like y equals mx plus b, where this b is the y-intercept, and this negative 1/3 is the slope. And that's all you need. So I'm going to say the y-intercept is positive 4. I'm going to count up 1, 2, 3, 4, and I'm going to put a point right here. That's my y-intercept. The slope is negative 1/3. And remember, that's rise over run. We always use rise over run for slope. Now it is negative, so I'm going to do, and remember, for when the number is negative, you can make the rise negative or the run negative, but don't do both. If you do both of them negative, negative over negative is positive, and you're right back to a positive 1/3. So I'm going to do the rise as negative. I'm going to move down 1 instead of up 1, but then for the run, I'm still going to go to the right. So to find a second point, it's down 1, right 3, put a point right there. And I drew the lines in for the notes. You don't have to. That's my rise over run there. Negative 1/3, down 1 over 3. Okay, now, here's where if I was graphing the line, I would draw the line. But I'm going to pause 1 second, because remember what I told you? We're going to do something different for the rest of this problem. The first thing I do is I look at the inequality. If it had the or equal to, then I would just draw a nice normal line, nice solid line. But since this one doesn't, I don't want a solid line. I actually want a dotted line. So I'm going to draw a dotted line or a hyphenated line like this that goes through those 2 points. Make that my line. Now, the answer to this question, the actual answer is either going to be everything above that line in the top right-hand corner, or everything below that line on the bottom left-hand, most of the graph here. Now, I'm going to shade the part that has the answers, but I have to figure out the part that has the answers. So what I told you is you can pick any number you want as long as it's not on the line. Now, for me, what I like to do, if it's not on the line, is pick the point 0, 0. Because those are the easiest numbers to plug in for x and y. You don't have to. You can pick any number you want that's not on the line. I'm going to pick 0, 0. So I'm going to go off to the side here, and I'm going to take my inequality. Y is less than negative 1/3 x plus 4. And I'm going to plug in 0 for x and 0 for y. I'm actually just plugging in 0 for both of them. So y is 0. We have 1/3 times x, which is 0, plus 4. Now, the reason I like picking 0 is because 1/3 times 0 is 0, and this whole thing basically just disappears. 0 is nothing. Negative 1/3 times 0 is 0, it's going to disappear. So what I get here is 0 is less than 4. And I ask myself, is 0 less than 4? And the answer is yes, it is. So what that means is that point where I pick, see the purple point where I put 0, 0? That is an answer to this question. But more importantly, it means it's on the right side. So the side that the 0, 0 is on has all answers. So I'm going to do this. I'm going to shade my graph like this. Color in this whole half of the graph. Everything on one side of the line. All of these are answers. Now, everything on the other side is not an answer. Like if you picked a point from maybe like positive 5, positive 5. You know, if I pick this point right here and I tested it, I'm not going to do the work, but it should not work. If I plug in 5 for x and 5 for y, I should get an answer that is not right. It should say something like, instead of 0 is less than 4, it might say 4 is less than 0, which is wrong. But any point, we just figured out, any point from above the line on the top right is not going to work in this equation, and every point below the line is. So the answer to this question is not an equation. The answer is not x equals this or y equals that. The answer is the graph itself. It's a graph with a line and half of the graph colored in. Let's try another one. All right, for this one, we are going to graph 2x plus 6y is greater than or equal to 12. We draw on a coordinate plane again. Now this graph is in what we called standard form, or what we sometimes call general form. It's not y equals mx plus b, so I don't know the slope right now. So what we decided when we saw this the first time is the easiest way to graph a line in standard form is using the intercept shortcut, or what I like to call the cover-up trick. And it basically says, like, if you just cover up each term one at a time, like if I say, let's say y is 0. If y equals 0, this whole plus 6 is going to disappear. And what I get is just 2x is greater than or equal to 12. And remember, actually, you know what, let me even take the greater than or equal to. When we're graphing the line, we're pretending like this is an equation for now. So the greater than would confuse you there. It's not necessary. Pretend like I'm just graphing the equal right now. So I say 2x equals 12. I divide both sides by 2, and I get x equals 6. That's my x-intercept. It's a positive 6. It's x, so I'm going to count 1, 2, 3, 4, 5, 6 to the right, and I'm going to put a point right there. Okay. Now we do the same thing with the y's. We say, let's say x equals 0, and this whole 2x disappears. Then what I get is 6y equals 12. We're pretending it's an equation for now. Don't worry about the greater than or equal to. I divide both sides by 6, and I get y equals 2. That's my y-intercept. Now if the y-intercept is positive 2, I count up 2, and I put a point there. Okay, so I'm at the same point as we were on the last question. I'm ready to draw the line in. I have 2 points. I'm ready to draw the line. I look at the inequality. This time I do see the or equal to, so I'm not going to do the dotted line. I'm going to do the solid line this time. I'm going to draw a solid line. Oops, I kind of missed there. Sometimes it's hard for me to draw on my computer screen. Draw the solid line like this that goes through those 2 points. That's a little better. And then I'm going to test again. Now remember, you can test any point you want, but remember my shortcut? If I can use 0, 0, I'm going to use 0, 0. So let's try it. I go back to my original equation. I'm going to plug in 0 for both x and y. I get 2 times 0 plus 6 times 0 is greater than or equal to 12. Now see, 2 times 0 is 0, 6 times 0 is 0, so I get 0 is greater than or equal to 12. Now 0 is not greater than or equal to 12. 0 is less than 12. What that means is the point that I picked was not on the side with all the answers. But remember, I don't have to test another point because it's one or the other. If the point that you test is not the side with the answers, then that means the other side up here is the one with all the answers. So this time the answers were all the ones up here on top. So that's how we do it. Step 1 is graphing a line. So you're going to have to remember how to graph a line from earlier in the year. You might use slope-intercept form, like our first example. You might use intercept tricks like this one, but that's something we know how to do now. So you got to graph the line first. Remember your 2 extra steps. If you have the or equal to, like this example, don't even think about it. Just draw in the line normal. If you don't have the or equal to, you have to remember to draw in a dotted or a hyphenated line instead of a solid one. And then the last step for both of them, whether it's a solid or a dotted line, is to shade. Pick any point not on the line. Remember, I like to use 0, 0 if I can. Okay, but you can pick any point. If you pick the point and it works, shade where that point is. If you pick the point and it doesn't work, like this example on the screen right now, then that's not the side where the answers are. Shade the other side.